Hello and welcome to Katala. Today we're going to be looking at surds, and this is the first part in the series for surds. Specifically, we're going to be looking at simplifying surds. Okay, that's going to be the main bulk of what we're focusing on today. So the learning objectives, the things we want to take away from today's lessons, are what actually is a surd, how do we simplify them, and how do you apply operations to surds. Operations, in case you aren't aware, is just referring to adding, subtracting, dividing, and multiplying. Okay, so let's get started. What actually is a surd? Well, a surd is a number written in square or cube root form, which cannot be simplified. Okay, some examples of surds would include the square root of 2 and the square root of 3. This is typically what surds are going to look like. Okay, now by looking at those two on the left, that you might be led to believe that, well, any number under a square root is surely going to just be a surd. But the key bit about surds is that they cannot be simplified. So if you look at the ones over on the right hand side, the square root of 16 and the square root of 9, well, we actually know that the square root of 16 is just 4 and the square root of 9 is just 3. Okay, so you've got to be careful. Not every single number under a square root is actually going to be a surd. Okay, over here you can see they're actually whole numbers just in disguise. All right. Now, the last kind of surds you're going to come across are ones which can be simplified. An example of that would be something like the square root of 12. Okay, and this is the main idea we're going to be discussing today. Well, the square root of 12, in actual fact, I think you'll agree with me when I say that 12 is just 4 times 3. So we can actually rewrite the square root of 12 as the square root of 4 times 3, since 12 is just 4 times 3. And now, one interesting thing you can do with surds is you can actually split up the square roots. And what I mean by this, if you ever have this situation where you have a square root with two factors multiplying by one another inside of that square root, you can split them up into their own sections and write it as the square root of 4 times the square root of 3. And if you don't believe me, I'd actually encourage you to go to your calculator, type in the square root of 12 and the square root of 4 times the square root of 3, just to make sure that they give you the same answer, so you're happy that they actually are exactly the same thing. Okay, now what's the point of all of this? Well, when you're in this situation here, you'll notice that the square root of 4 is actually just 2. Okay, and so what we can do is rewrite this as 2 times the square root of 3. And because as mathematicians we're quite lazy, whenever you have two things multiplying by one another, you can actually just write them next to each other. That's understood that it's just meant as 2 times root 3, if you have 2 root 3 next to each other, okay? So the key part to this one here is we had to choose appropriate factors to break down our number 12 at the beginning, right? Equivalently, what we could have done, technically speaking, is we could have taken the square root of 12 and rewritten it as the square root of 6 times 2, because 6 and 2 are also factors of 12. And again, we can split these up to be the square root of 6 times the square root of 2. Now, the reason why I didn't select those factors is because you'll notice at this point here, neither of those numbers, 6 or 2, are actually square numbers. So that does not simplify in this way here. So it only ever works if you can actually spot a square number that goes into your original number. Okay, if there's no square numbers that go into it, you cannot break it down. Okay, so put a cross through there so you know you cannot simplify it in that manner. Okay, so if we scroll down and have a look at some examples together. Okay, we've got the square root of 18 to get started. Okay, well, remember, like we said, we've got to spot square numbers that go into this number. Now, the square numbers, if you aren't fully aware, are just 4, which is 2 squared, 9, which is 3 squared, 4 squared is 16, 5 squared is 25, 6 squared is 36, and so on, okay? There are obviously an infinite amount of square numbers, but typically with the questions you're going to be coming across, it's going to be one of the smaller bunch up to here, okay? So, square root of 18, let's focus on that. What number is going to be a factor of 18, which is also a square number? So we're using those numbers on the right hand side that I just listed. Okay, well, we can see that 9 is definitely a factor of 18, so this allows us to write the square root of 18 as the square root of 9 times 2, because 18 is 9 times 2. And like I said, you can split those square roots up from this point here to get the square root of 9 times the square root of 2. And since you know the square root of 9 is just 3, we can write this as 3 times root 2 or 3 root 2. Okay. Now, next one down here, okay, we've got 3 root 20. Okay. Now, 3 root 20, like I just said, because we're lazy, we like to just write things next to each other, knowing that they actually just mean times by, is just really 3 times the square root of 20. Now, this 3 here on the outside isn't really doing any harm and doesn't need any simplifying by itself, okay? What we've got to focus our main attention on is breaking this quite a large number down inside this square root down first, okay? And that's the top tip I can give you for these, is if you ever see a large number inside of a square root, be slightly suspicious because it's often going to need cancelling down, okay? So let's focus our attention on the square root of 20. Well, the square root of 20 we can write as, using our square numbers on the right, the square root of 4 times the square root of 5. So what I've done this time is I've skipped this middle step here that we did on the previous question. If you feel like including it, by all means, we're just going to speed up the process slightly, okay? And this then is just equal to 2, because the square root of 4 is 2, root 5. Okay, so we know that the square root of 20 is the same as 2 root 5. And this has been multiplied by 3. So we've got 3 times 2 root 5. And I've seen a lot of confusion at this point here with some students. Now, when you have 3 times 2 root 5, such as this, okay, I've seen a lot of people try to multiply the 3 with the 5 and the 2, okay? Well, the way of thinking about it, okay, you currently have 2 root 5s here, okay? You have 2 lots of root 5, and you're multiplying those by 3, okay? So you have 3 lots of 2 lots of root 5, which is going to give you 6 lots of root 5. An equivalent explanation, okay, when you have something like 2x, and you're timesing that by 3, so 3 times 2x, you have 6 x's. And in exactly the same way, up here, 3 times 2 root 5s is going to be 6 root 5s. Okay, and that would be your final answer there. So let's just clear this here. Now, last example here, 6 root 50. It's very similar to the last example. You're just aware that 6 next to root 50 just means 6 times root 50. Now, let's break root 50 down. Let's focus our attention towards this here. Okay, so the first square number that I spot, and it does take a bit of getting used to spotting the square numbers that go into the numbers that you're given. You do sort of get a knack of it after practicing a few questions. The first square number that I spot that goes into this is the square root, is 25. So we can rewrite this as the square root of 25 times the square root of 2, which is just going to become 5 root 2. And if we go back to the question, it's been multiplied by 6. Well, if we had 5 root 2s and we times that by 6, we now have 30 root 2s. So 6 times 5 root 2 is 30 root 2. And there's your final answer there. Next up, we're going to look at operations with surds. So like I said, your division, your multiplication, your addition, and your subtraction. Now, the first one here we're going to be looking at as fractions, so there's division involved in these ones, okay? Now, the key point to surds involving fractions is you just got to do the same to the top as you do the bottom. So you can see that we're square rooting the whole fraction. We've got the square root of 3 over 4. Well, all we've got to do is do the square root of 3 over the square root of 4. Now, the square root of 3 does not simplify. We can't break that down in any way. So we just leave it as the square root of 3. And the square root of 4 on the bottom is just 2. Okay, and there you go. There's your final answer. We can't simplify that any further. Now, the square root of 12 over 25, we could just rewrite as the square root of 12 over the square root of 25. Now, the square root of 12, I've got a suspicion we are going to be able to break that down. So we'll focus on that in a second. And the square root of 25 is just 5. So it's going to be something over 5. And if we just sort of focus on this top bit here, if we bring that over to the right, the square root of 12. Okay, well, any square numbers that go into there? Well, definitely we have 4. So we can rewrite this as the square root of 4 times the square root of 3, which is just 2 root 3. So in other words, the square root of 12 is just 2 root 3. So we can just put that on top now here to get 2 root 3 over 5. That doesn't simplify because there's no common factors in 2 and 5. Okay, last up, for division anyway, is the square root of 18 over 81. Now, that's the same as saying the square root of 18 over the square root of 81. And the square root of 81 is just 9. Okay, because 9 squared, 9 times 9 is 81, so the square root of 81 must therefore be 9. And the square root of 18, I think we're going to be able to break down a bit. It's not a square number, so it doesn't simplify nicely. But because it's quite a large number, I suspect we might be able to break that down. So let's have a go at that. Square root of 18, let's take that over here. And we've got 9 is a square number that goes into 18. So it's 9, square root of 9 times the square root of 2, which is just 3 root 2. And so that goes on top there. And this one is slightly different from the others because you'll notice you have a 3 on top and a 9 on bottom. Now, there is going to be some cancellation here because you've got 3 root 2 over 9. So you can actually divide the top by 3 just to give you root 2 and divide the bottom by 3 to give you 3. And so you just end up with the square root of 2 on top and 3 on bottom. They just simplify like normal fractions, just as 3 over 9 normally would. It becomes 1 over 3. In this case here, because we have 3 root 2 over 9, it's just going to be 1 root 2 over 3. And we just drop that invisible 1 in front of the root 2, okay, because it's not necessary. It's understood that root 2 by itself just means 1 root 2. Okay, multiplication next. So we've got 3 root 2 times 4 root 8. Now, a good idea with these is actually to keep them kind of separate. So what I mean by that is it's a good idea to times the numbers together and times the square roots together and then sort of tie it all together at the end. Okay, and that's what we're going to do in this case here. So 3 times 4 is just going to be 12. Remember, this is all multiplying together. So times the square root of 2 times the square root of 8. Now, the square root of 2 times the square root of 8. Let's think about that. Times square root of 8. Okay, so using the sort of reverse of the idea we've been establishing so far today, the square root of 2 times the square root of 8 we can put back under a single square root to give you the square root of 2 times 8, which is 16, and that is just 4. So in other words, the square root of 2 times the square root of 8 is just 4. So we have 12 times 4, which is just 48. Okay. Next up, 2 root 5 times 4 root 18. Now, we could use the exact same technique. We could say, well, 2 times 4, and the square root of 5 times the square root of 18. Now, the 2 times the 4 is perfectly fine. That's just going to be 8. But the square root of 5 times the square root of 18 is going to give you quite a large number that might prove a bit difficult to break down. So what I'm actually going to do first is break it down at the beginning. So we're going to take root 18. Okay, it's worth noting that square root of 5 is not going to break down any further. That's as simple as we can express that. The square root of 18, I believe, will break down fully. So we're going to break that down first. So the square root of 18, we can write as the square root of 9 times the square root of 2, okay, which is just 3 root 2. And there you go. The square root of 18 is just 3 root 2. So if we put that back in, okay, actually before we do 2 times 4 to give us 8, we're just going to do it from this point here. So 3 root 2 is the same as the square root of 18. And if we pop that back inside, what we're going to have is 2 root 5 times 4 times, okay, so remember 4 root 18 means 4 times root 18 essentially. The square root of 18 is just 3 root 2. Now, 4 times 3 root 2 is just 12 root 2. So we've got here 12 root 2, and that has been multiplied with 2 root 5. And so now if both those brackets are as simple as they can be, so both those square roots are as simple as can be, we can just expand as normal as we did before, times this out. So 2 times 12 is going to give you 24, and the square root of 5 times the square root of 2 is just the square root of 5 times 2 is 10. Okay, and 10 we can't break down any further because there's no square numbers that go into that, so that would be your final answer there. Question number 6. Okay, so we're looking at addition and subtraction now, just to finish up with. We have 2 root 18 plus 5 root 8. And now it's worth noting for addition and subtraction, you can't blend together these numbers unless they're exactly the same. What I mean by that is you cannot add, for example, the square root of 2 plus the square root of 3. They don't mix, okay? It's like trying to add x plus y. Okay, you can't combine those together because they're completely different things. So we must keep them separate. The only way we can actually bring them together would be if it's something like the square root of 3 plus the square root of 3. Well, that's just two lots of root 3. So 2 root 3s. Simple as that, okay? So if we use that, bear that in mind of our example, you can see in its current state, we can't actually add those together. So we're going to do something a little bit clever here, okay? And like I've said previously, if you ever get quite large numbers under these square roots, just be slightly suspicious of them, okay? So we're going to break this and this down first. We're going to focus our efforts on those. We'll bring those over to the right. So the square root of 18 we'll do first. Is just the square root of 9 times the square root of 2, which is 3 root 2. Brilliant, so that breaks down to 3 root 2. And the square root of 8 is equal to the square root of 4 times the square root of 2, which is 2 root 2. So in other words, you know that the square root of 18 is just 3 root 2, and the square root of 8 is 2 root 2. So if we put those back in there on the left, we'll have 2 times the square root of 18, which is 3 root 2, plus 5 lots of 2 root 2. So 2 times 3 root 2 is 6 root 2, plus 5 times 2 root 2s would be 10 root 2s. And if you had 6 root 2s and you're adding 10 more, you're going to have 16 root 2s. And there we go. That's as simple as it gets. Question number 7. So 3 root 54, take away the square root of 24. Again, quite large numbers. It's a good idea to try and break those down at the start if possible. So let's do that here. So the square root of 54 and the square root of, the square root of 24. Let's just break them off to the right over here. So the square root of 54. Now, straight away, the square number I noticed that goes into that there is 9. So we can rewrite this as the square root of 9 times the square root of 6. And like I say, you do just sort of get the knack of what square numbers go into which numbers after practicing a few questions, okay? And that is just the same as 3 root 6, since the square root of 9 is just 3. And the square root of 24 is equal to the square root of 4 times the square root of 6. And that's just 2 root 6. And again, putting those back in the original question, we have 3 lots of root 54, which is the same as from over here. Root 54 is the same as 3 root 6. So we have 3 lots of, so 3 times 3 root 6. Take away the square root of 24, which is 2 root 6. Now 3 lots of 3 root 6s would be 9 root 6. Take away 2 root 6, which is just going to be 7 root 6s. And that's the end of the video. I hope you've enjoyed. See you soon. Thanks again for watching. For more great resources to help build your confidence and ace your exams, feel free to head over to www.katala.co.uk, where you can sign up for free today. If you enjoyed the video, please like and subscribe. And if you have any questions or suggestions, just comment down below. Thank you.